We are at 1:03, so we will get started if that sounds good to everyone. Thank you all for joining. And as a final reminder, if you just joined, there's a link in the chat, so please be sure to check in. And this way you can enter the raffle as well. So we are very excited today to have NVIDIA be one of our expeditions. And this is virtual, very excited to have them. And just a little housekeeping notes. I wanted to make sure that everyone keeps their microphone muted until the very end when we have Q&A. Feel free to unmute yourself at that time, or also use the chat. We encourage you to turn on your cameras if you feel comfortable. Our speakers would love to see your amazing faces if you are, again, comfortable. And then we also wanted to let you know that live transcript is available, so feel free to use that if you would like. And without further ado, I will introduce Serena Cheng, who is our NVIDIA's University Recruiter. Take it away, Serena.
Thank you, Sylvia. Hi, everyone. Thank you so much for joining us today for the University of Michigan ECE Expedition. Thanks to Sylvia and Anne for helping us organize this. We're super excited to have the opportunity. Oh, did someone? Yeah, we're super excited to have the opportunity to meet and speak with you all virtually. So my name is Serena. I am a campus manager on the university recruiting team here at NVIDIA. Along with me today is Kave, who is one of our hardware university recruiters. So maybe if we can wave, you can all see him. So today we have a pretty casual agenda for you. I'll kick it off with a quick introduction of NVIDIA, and then you'll get to hear from 3 awesome University of Michigan alumni who will talk a little bit about their team, what they do, and you can learn a little bit more NVIDIA that way. I'll then talk about opportunities and ways you can connect with us after the talk today. And at the end, we'll save some time for Q&A and also pick the raffle winner. So definitely make sure to check in. So whether you're here to learn more about NVIDIA or you're interested in opportunities with us, I really hope that this session will be useful and informative. This is casual, so feel free to open up your webcams. We'd love to meet you. And again, feel free to type in any questions that you have into the chat. All right, so I'm not sure if we have any gamers in the crowd, but many students, especially gamers, they may know of us for our GPUs, which revolutionized video gaming by developing real-time rendering on modern computer graphics. So many of the beautiful images you see on the video games or even movies today are supported by our GPU. So even if you're not familiar with NVIDIA, our technology is definitely all around you. Today, NVIDIA is the maker of accelerated computers for scientists, engineers, and artists that enables them to envision and create the future. Something our CEO says is he likes to compare us to a time machine, as NVIDIA products truly allow scientists to simulate the future and see it in real time. Here on this slide, you'll see a picture of our new campuses called Endeavor and Voyager. The design is based on triangles, which is the main primitive in 3D graphics. So it's really awesome that even the architecture reflects our passion for the products we build. Next, I'm going to play a short video to show you a small portion of the innovation that NVIDIA enables. Okay.
Creator. Blending art and technology. to immerse our senses. I am a healer, helping us take the next step and see what's possible.
Wow.
Can you really see?
Yes.
Oh my.
I am a pioneer, finding life-saving answers. And pushing the edge to the outer limits. I am a guardian, defending our oceans.
Under that flyby inbound.
And the magnificent creatures that call them home. I am a protector, helping the earth breathe easier. And watching over it for generations to come. I am a storyteller, giving emotion to words and bringing them to life. I am even the composer of the music. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
That video gives me chills every time I watch, and it's just a glimpse into some of the cutting edge technology we developed here at NVIDIA. So moving next, we work on so many cool things, and at our core, NVIDIA builds fast computer chips, GPUs, DPUs, and CPUs. But delivering industry-leading performance requires so much more than just powerful chips. We don't just focus on speed up for performance on a single chip level, but we put a lot of focus into full stack optimization. So NVIDIA develops the systems that these chips run on, from graphics cards to servers to embedded systems to entire data centers, designing the algorithms and platform software that gets run on the hardware, and also optimizing the industry applications that run on top. So we start with amazing chips, but for each field of science, industry, and application, we actually create a full stack. I think all in all, we make computers for the Da Vinci's and Einsteins of our time so that they can see and create the future, just as you saw in the video earlier. So today, we are an AI computing platform company, and our GPU is the heart and brains to applications ranging from self-driving cars, robotics, healthcare, HPC, and so much more. AI, the most powerful technology force of our time, is a fundamentally new computing model that is reshaping data center architectures. And I think something that makes us really awesome is that we are a company that passionately believes in our mission. We want to be the most awesome processors in AI. And today we are a learning machine that is constantly evolving, and by adapting to new opportunities, we solve really hard problems that only we know that we can tackle. So that's really something that's special to NVIDIA. I think hopefully that gave you a brief overview of what NVIDIA is about. I'm going to go ahead and transition this to our University of Michigan alumni now, where you can learn a little bit more about them, what they do, and more about the company. So with that, I'll go ahead and pass it over to our first speaker, Janelle.
Thanks, Irina, and thank you everyone for joining. So I kind of was in the same boat as you guys about 5-6 years ago. I know that makes me sound a little bit old, but yeah, stick with me. So yeah, I actually finished my master's degree uh, in December 2015, and then I actually joined Intel for about 4 years, and then I joined NVIDIA like about 2 years ago. And like I'm part of the circuit solution group, and I specifically work on an IP which is called like adaptive voltage and frequency scaling. So you all know that when you play computer games versus when your phone is just sitting idle, it takes less power when it is just in idle mode versus when you're playing a computer game, right? So like I work on an IP which enables that feature. So yeah, I think I'm just like here to like share my experience like in so far in the industry, and if you guys have any questions, I would be happy to answer. So I understand that there was like a questionnaire which was sent during the registration form, and there were a few questions about what all job opportunities are available in hardware. So like I prepared like like a slide, and I'm gonna go over that in terms of what all roles we have available in hardware and how what you study at Michigan can be translated into an industry role. So can we move on to the next slide, please? Okay, thank you. So again, this is like a very simplistic version of the different hardware roles which you would encounter when you are applying as an NCG. And like in reality, a lot of these roles are very cross-functional. But if I had to put them in buckets, I think I would divide them into these separate buckets. So I am personally involved in circuit design. So I work on an IP, as I mentioned, which enables the adaptive voltage and frequency scaling. But apart from circuit design, there are like four other different fields which you would encounter. So one is physical design, then RTL design, architecture, RTL verification, and CAD and methodology. So I think like I have kind of mentioned the courses here, depending on what you study at Michigan could be applied into your industry role. So for example, if you are involved in a circuit design role, you would probably be working with you'll definitely be using what you studied during your 312 class. And if you were to further divide into specialization in circuit design, it kind of goes more into digital and analog circuit design. And like if you are on digital circuit design, then the things which you studied during 427 and 627, that is what you're going to be using in your day-to-day work. And for analog circuit design, it's going to be 413 and 522. So yeah, I think so. This is just kind of give an example that what you study and what you do would apply to an industry role. So for example, if you're going to be doing physical design, then the essentially your 627 project is essentially what you're going to be doing in physical design. So if you really like doing 627 project, then physical design could be a good starting point for you guys. Again, for RTL design, I think 270 is like a basic building block for what you would do in RTL design. But again, what you learn during 427 and 470 is going to be used when you actually do the design work. The same thing applies with architecture, RTL verification. It's like a very cross-functional role, but if I had to put them into buckets, this is how I would put them. And so whenever you're looking for any like jobs, just like try to ask as many questions as possible, that what's a day-to-day role is going to look like, and then maybe you can relate to what you actually study, and then figure out like what role do you want to start off with. And yeah, I think so. The next section is CAD and methodology. Like we have another speaker like who's actually working in that team, so she'll probably be able to represent that role much better than I can. But yeah, I think so. This was just like a brief overview of like how what you study would be connected to what an industry role would look like. And I think like I've been in industry for like about 6 years, and I can say with very high confidence that this is probably the most exciting time to be in hardware. I think there are a lot of job opportunities available. Like I get messaged on LinkedIn almost every week, hey, like are you looking to move and switch? So yeah, I think just explore all the options you have. I just want to say that NVIDIA is a really good company if you're trying to learn, if you're trying to explore different field. The work culture, which is kind of dictated from higher up, CEO, is very open and very like friendly. So, I mean, I've been into, although like NVIDIA has grown significantly in past couple of years, we still have been able to maintain like a little bit of startup vibe. But again, we work on many products. So yeah, with that, I'll hand off to Dora, who's also like a Michigan alumni, and she's working on CAD and methodology, and maybe she can elaborate a little bit more on that role. I'll be here for the Q&A, so if you guys have any specific questions, I'll be happy to answer. And like, yeah, we are essentially hiring in all this field. So yeah, if you're looking for a job, yeah, please connect with Serena or apply on the careers page. We are hiring in all the fields.
Okay, yeah, thanks, Janal. I'll add a few comments on this current slide before moving on. So I do work in CAD and methodology. It's kind of a field that is very important and very underrated, in my opinion. Essentially, when we say methodology or CAD, we're referring to all these tools that take your description of how the chip should work, which is captured in system Verilog or Verilog code, and then translates that in a series of steps into photolithography masks that you can send to a chip fabrication facility. So it's very complicated. There's multi-steps, there's dozens of tools that you need to use. And if you work on the CAD side, you are in charge of creating flows and maintaining flows that are used by every single designer at NVIDIA, trying to make their designs better, right? The way I see it is, the thing that really sold me on CAD and methodology work is that if you're a designer, you can make a great improvement and you'll impact a small part of the chip, right? Like you have a chip, everyone's assigned a small IP, and your job is to make that better. And you can make obviously a big impact with that. But with methodology, if I can make my tools and my flows better by some percent, that percentage will be multiplied across the chip because thousands of people are using my tool. These improvements will stack on top of each other. So I think that impact is really cool, and that's what ultimately made me want to go into this field. And if you are curious about CAD, you'll get a taste of it in ECE 427. ECE 478 is specifically about synthesis, and also ECE 627. I think by the time you're in 627, the projects are so complicated, and the scale is so much larger than 427 that you are using these tools way more heavily. So you'll get a good taste of that. If you like that, I think this could be a good role for you. I kind of feel like sometimes I'm just in 627, like on a normal day. So yeah. Serena, can you move to the next slide? Okay, so with that said, I'll talk a bit about myself. So I graduated from Michigan with my undergrad degree in 2017, December. And then I interned at NVIDIA for 7 months after that, before I started the SUGS program. And after the SUGS program, I did join in my same team that I interned in, but on like a different half of the team, doing a different project. And my team is responsible for the development of, and support of all front-end physical design methodology tools. So I'm talking about synthesis, RTL analysis, clock domain checking, and a little bit of place and route. And don't worry if those aren't familiar to you. I'm not sure what the distribution of the audience is, but you can get a taste of all of those in ECE 427, 627. Yeah, I think that's what is so valuable about those courses, because once you start working in industry, you are working on a specific thing, right? The chip design process is so long, but you'll be working on one sector of it. But when you're in these classes, you can write some RTL code and then take that all the way to tape out, which is pretty incredible. And you're using all these tools that we use in the real world. So it's very applicable. Yeah, so my recommended coursework is definitely 470 to understand computer architecture and become an expert at writing system Verilog, 427, 627, and also whatever like 598 course you think is interesting. I can't recommend that enough. I took one about hardware for machine learning taught by Zhenya, and that was awesome during my master's. Let's see. So I had interned at NVIDIA for 7 months. And I ultimately decided to go back. I think it was mainly just because of the culture. I think there's a very open culture in VLSI where there's a lot of information sharing. You're always constantly learning what other teams do. You know, once we were just curious, like, how are the fans designed for our latest 3080 GPUs? So we had the person who designed the fans in a whole different area of the company come and give a presentation, very technical, very detailed, how the fans are designed. I just really like that culture. You can always learn something new. And if you're curious, you can like reach out to those people. People are very open about talking about what they do. And I think this culture is quite different from that of some other tech companies. And I really believe in our CEO's mission. I think even as an intern, you like go to company meetings, you can sit in front row if you want. And just hearing Jensen talk about how we only want to solve difficult problems. We are not interested in just making, in competing with companies to make the cheaper GPU that will be in X product. We want to solve problems that have not been solved before that other people can't solve. So I think that mission is very admirable, and we want to create new markets for ourselves. So yeah, I guess some parting words that I would say is I didn't really know this job role existed when I was a student, which is so cool that Michigan is holding events like this. I think most people probably don't even know what their dream job is when they're still in college. They don't know that it exists. So my advice is just to keep attending events like this, keep talking to people, and find out like what's even out there.
Also, I think the interns used to have like a party at CEO's place, right, before COVID?
Yeah, that was awesome too.
That was definitely before COVID, so things will definitely change post.
For sure.
All right, Dora, should I pass it over to Eric?
Yeah, I think that's it for me, but I'll be here for questions too.
Hi, glad to see everyone. I'm Eric. I guess I'm the only software engineer here. I graduated in 2018 in computer engineering at Michigan. I later did my master's in electrical engineering, and then now I'm on the AV team. So I interned at NVIDIA twice before. So one was in GPU software. And then from then I was able to talk to other teams, and I found a AV role for my next summer's internship. So then I was able to move there pretty easily. And then I stayed after my internship on AV. So AV is a very large organization spanning from, the chips that go into the car versus the final actual software that goes in the car to drive it. And we do the whole thing. Specifically, we're working on perception, which is how the car can use all the sensor data to see what's in the world so it can drive safely. And my role on the perception team is working on generating a lot of data for our neural network models to predict in a lot of different situations. So that requires a lot of data. It requires being able to generate this data quickly and efficiently, because generating labels for this data requires some sort of human input, which is usually a big bottleneck in AI systems. So I'll talk more about, what perception is and our AV team later, but in general, if you want to do AV, I think there's a bunch of roles that you could fit in. As I said, there's hardware, there's embedded, but if you want to go more on the algorithm side, I think definitely computer vision or robotics is a very good background to have. So I'll recommend those, and depending on whether you want to focus on perception, like computer vision, definitely take computer vision. Or if you want to do more of like planning and controls, then maybe autonomous robotics, that course would be really valuable. But both are really good, solid backgrounds to have in AV. Can you go next slide, please? Yeah, so I just want to show you a cool video. It's always cool to have AV videos of our car driving. Could you play, please?
Solving for autonomous driving is a huge engineering problem, and the way that we tackle that here is through a divide and conquer approach, where we tackle one critical piece of functionality at a time. And each of those pieces of functionality we call an NVIDIA Drive AV mission. And today's drive mission number 62, is called Path Perception Ensemble. In this drive mission, we leverage an ensemble technique, which is a machine learning method that combines several base models and produces an optimal predictive model. In our path perception ensemble, the base models include 3 different deep neural networks: LaneNet, that you see here in yellow, PathNet, shown in orange, and PilotNet, shown in blue. These DNN outputs, along with the output of a high-definition map, are combined into our path perception ensemble output that you see here visualized by the thick green center path lines predicting the center path for the ego lane, as well as the left adjacent and right adjacent lanes. In this clip, we see path perception ensemble in action in a construction zone, in dense traffic, with pretty much no lane lines on the road. And the white lines you see are actually computed by ensemble. They are not physical lane line markings. That center path is still green, which shows agreement between the underlying path perception ensemble components. When they start to disagree, it turns yellow, and when disagreement gets stronger, it becomes red. The results of this analysis can be used to determine when autonomous operation is safe and when control should be properly transitioned to the human driver. In this video, we are using Path Perception Ensemble for a series of autonomous lane changes. The ego lane that we're currently in is visualized in green, left adjacent lane is shown in red, and right adjacent lane is shown in blue. And as we change lanes, the color scheme changes accordingly. You can also see that the color of the obstacle fence computed for each car changes as cars move to and from different lanes. This functionality was incubated from scratch through our NVIDIA Drive AV mission number 62, Path Perception Ensemble, and it will be shipping in the NVIDIA Drive Software 9.0 release.
Okay, cool. So there you just saw a subset of the stuff that we predict in perception. And so at the heart of it is deep neural networks, which are just machine learning models that take in a lot of data to train and then give an output. And so I want to present to you like more of a general AV or AI like production pipeline, because I think there may be a misconception that it's all, you have to know deep learning, but deep learning is just, at the center of it. There's a whole pipeline that goes around it. And it's a very data-centric process because these models are kind of just black boxes. And in order to monitor how they perform, we need to make sure we input the right data into these black boxes and measure the performance and the improvements that we get out of them. And also this pipeline incorporates a lot of our key NVIDIA technologies. So a lot of people ask, or they're surprised that NVIDIA is building a self-driving car from scratch. Well, one of the reasons we can do that is because we have all these key technologies like GPUs that go in the data center and also in the car, state-of-the-art, rendering for photorealistic simulations, and definitely deep learning research. So we can incorporate all these together to actually be the company that accomplishes the hard task of self-driving cars. So on the left, we have to collect a lot of data for for our models to train on. And so we have cars that run our software with the NVIDIA drive chips, as well as our sensor set. And then once we get all the sensor data, we need to apply a lot of labels on them. So one easy way, maybe a too simple way, is to get a bunch of people, clicking on an image to draw boxes and lines for lanes and cars, but that's definitely too slow and too cost inefficient. So what I do for generating this data is something called MapGT, which uses maps like HD maps that we create. And so when the car drives on these maps, we can localize to the map and get a lot of lane information without having to manually draw it each time. And there's other stuff we could do to automate the labeling process where we don't have to just manually, label images with shapes and stuff. And then we get these data sets, which we train our deep neural networks on. We have our own cluster that runs NVIDIA GPUs. So it trains super fast. And then once we create these models, they're all deployed. Basically, we have all these modules that detect, let's say, lanes, cars, traffic signs, pedestrians. They're all put together in the actual Drive AV software. So that incorporates planning and control, that incorporates all the safety features that actually actuate the car. And then finally, want to make sure that this is safe. So one way to do it is test it on road in the car, but that's also, one, we can't get all the scenarios that we want. And two, it takes time to, drive on a road. And three, it could be dangerous. So we also have a vast array of simulation things we can do, which one is Drive Sim, which is we're able to photorealistically render all of the sensor data so that we can change the driving scenarios and basically drive the car in the cloud like a video game and test our performance and how well we do in the cloud. So there's a lot of stuff that goes on in AV. You can actually choose to do a lot of things, and it's not just, you have to be a deep learning expert. And I think that's one cool reason to join AV, is that I think no matter what, you can find a project that you'll like, and you can always move around to accomplish our goal finally of creating this this platform for any AV developer, let's say our partners like Mercedes or Jaguar, to really create their AV products. Okay, so I'll also be around for the Q&A.
Thank you, everyone. Yeah, thank you, Eric. Right, so that was all so insightful. I think whether you're looking to join NVIDIA or you're thinking about what you want to do and where you want to work, I hope that you were able to take something away from the speakers. For those who are interested in opportunities with NVIDIA, I'm going to quickly go over how you can apply and what next steps looks like. So with that said, as you've heard, we are currently still hiring for interns and new college graduates in all areas, ranging from technical roles in research, architecture, hardware, software, to non-technical roles. On top, you'll find a bit.ly link to our job description packet, and that should give you a pretty good overview of our general hiring areas. So definitely check that out. We also hire interns year-round. So if you already have an opportunity this summer, but maybe taking a gap quarter, we definitely do look for fall and winter interns as well. So note that our internships are a minimum of 12 weeks long and are full-time, so 40 hours a week. Next, I do want to share with you all of some of the many benefits our company offers. I think making NVIDIA an inclusive and diverse company to work at means that we do need to provide benefits that support everyone. So just a few I want to highlight today. And first is our student loan repayment program. So if you graduated within the past 3 years when you join as a full-time, you can actually apply for reimbursement of $6,000 each year to help repay your student loans, and up to a total of $30,000 in all. So I know this benefit is extremely helpful to many of our new college graduates, and so many do take advantage of this. Next, we have our employee stock purchase plan, also known as ESPP, which is actually one of the best in the tech industry. You can actually contribute up to 15% of your salary to purchase NVIDIA shares at 15% discounted price. I can't stress this enough, but this is truly a great benefit and great investment. And if you have been following NVIDIA over the past few years, you will have known the great growth we've had in our stock. Lastly, for those who would like to continuing to take courses and learn after they join full-time, we do have great partnerships with different universities. One is with Stanford Center for Professional Development. This is a program that enables our employees to take courses and certificate programs with no out-of-pocket costs. Many times I've seen a lot of our new college graduates who continue to pursue their master's while working full-time with NVIDIA. So it's a great benefit. Really, these are just a few of the many great benefits we provide for our employees. No matter what role or stage of life you're in, we provide opportunities and benefits that support everyone. So you're probably wondering now, how can you actually apply to NVIDIA and what the application process looks like after this event? So if you haven't checked in already, make sure to do so on the bit.ly link on the slide. This will allow you to let me know that you're interested in opportunities and when you're available. After today, I'll be reaching out with a follow-up email with details and directions on next steps. And then on my end, we will share your profile with relevant teams that you're interested in directly. If there's a fit or interest, we'll reach out with next steps to schedule a screen. For internships, it's 2 to 3 phone screens. And then for full-time roles, it's 2 to 3 phone screens with a virtual on-site. And happy to answer any other questions that you may have on the application process later on. And then even if you're not available or interested in opportunities right now, check in. So you're entered into a raffle. And if anything changes in the future, you always have a contact at NVIDIA to reach out to. Right. So lastly, there are so many other ways you can connect with us, and there's so many great resources for students and researchers. There's one that I want to highlight that's happening next week. Next week, we are hosting our premier AI developer conference, GTC, where you get to hear about the latest breakthroughs in AI, HPC, graphics, networking, and so much more. So if you attended today's session and you aren't necessarily interested in the teams that were here today, GTC is a great event to learn more about the other areas and challenges that we are working on. There's going to be hundreds of talks, demos, and presentations from luminaries and leaders from around the world. And the best part of all of this is that you can register for free with your university email. So I'll definitely, include this information in my follow-up email after today's event in case you're interested in signing up. But I definitely encourage you to check it out next week. So before we get to Q&A, I'm going to just play, one last video. And it's a video on our interns from last summer. One second.
Ever since I was a little kid, I loved to solve problems.
If you think about it, they're really just challenges or puzzles that you get to figure out on your own.
At my core, I am a problem solver. I loved taking my classroom skills and deploying them in the real world to solve real world problems.
So I know that my tiny little changes on the GPU firmware team can then propagate down the chain and affect so much more.
And getting to make an impact on the next generation of problem solvers that we have here at NVIDIA.
I believe this is the ability to apply your knowledge and your skills in a way that you can create a positive change in your family, in your group of friends, or even in the community where you live.
Create custom device drivers, implement Linux kernel features, and then also some low-level Android frameworks.
I assisted my team in testing every single feature and setting in GeForce Now to ensure that the next upcoming version of GeForce Now is ready for the user with no bugs.
Help facilitate NVIDIA's virtual internship program. We had to create a welcoming environment virtually, which had its challenges but led us to come up with some pretty creative solutions.
Finding a tool to auto-generate API documentation for a particular driver layer of NVIDIA RISC-V SDK.
Automating the Android signing process.
Making sure that our graphics card drivers load games as quickly as possible.
Definitely the talk with Jensen, as well as being a part of the Hispanic Latina network and going to the events.
The excellent mentorship, as well as the great support system that surrounds NVIDIA.
Your work matters to your team and won't get tossed out after you leave.
And one of the most exciting parts of my internship is seeing that my bugs were going through and helping the team solve issues that I found with GeForce Now.
My work with DAS SQL was even acknowledged by Jensen, which was super cool.
Ask as many questions as you can and try to meet as many interns as you can.
Challenge yourself, learn from every experience, and have the courage to try something new.
Just do your work, try your best, ask for help if you need it, and be able to great.
Just believe in yourself. You can do whatever you put your mind to do, and you will do great.
The work that the interns are doing here really matters.
We are problem solvers. Want to join?
All right. So we'll go ahead and open it up for Q&A now, and then pick the raffle winners at the end. So you do still have some time to check in if you haven't done so already. I guess we can, let's see. I have folks raise their hand or unmute themselves to ask questions.
Yes, that sounds great. If any students, if you'd like, feel free to either unmute yourself or you can put your questions in the chat and the speakers will be happy to answer them.
One question just came in. What kind of work does the firmware team do? Not sure if any of our speakers can help answer this.
Yeah, I don't know. I think, I don't think, maybe Eric, I don't know if he has a little bit more insight into firmware team.
Yeah, I don't know. It's just in general firmware, what you would expect it to be is writing the software on a low level, bare metal, interfacing with the GPUs. And that's all my experience with that.
Yeah, we knew some people who worked on the drivers team. Those team hire pretty heavily for interns. And yeah, they write our drivers. That's all I can tell you.
Some of the skills the firmware teams are looking for: embedded operating systems courses, computer architecture, all will come really handy. So if you have any experience in C++, our firmware teams would love to talk to you. Yeah, very low level, close to the hardware. And that's why those courses would come in handy. see. How easy or difficult is it to switch between different departments? For example, architecture to software. Something that's really cool about NVIDIA is I think it's very fluid and it's very encouraged for employees to explore other teams and departments. So even our interns that join, they might join full-time on a different role, as you've seen with Eric, and even full-time employees that have been here for a long time. You'll see that they've been here for a long time and they've have switched into different teams and roles as well. So I don't think it's hard, but the teams would be looking for relevant skills if you were to switch, teams. Hopefully that helps. But it's definitely encouraged. Our CEO even encourages, exploring other teams. We actually have had an internal open house in the fall for employees to explore, those different roles and teams within NVIDIA. So really cool. Let's see. So if you had applied online and you haven't heard back, one of the perks of attending these events is, submitting your resume in the check-in form, which we'll, review later and pass on to the teams directly. So if there's a fit or interest after this event, you'll probably hear back within 2 weeks or so. All right, I think this question is maybe Eric can help answer. What type of roles are available related to autonomous vehicle functional safety? What experience is required for the same?
Yeah, so I think there's two aspects to that. There's one that's hardware and one that's software, right? So one is making sure that all the hardware requirements for vehicles are met, as well as like redundancy, making sure we have always a backup, and making sure we always do computations twice and double check them. But also on the software side is mostly it has to do with testing and making sure that all of the requirements are met. So a lot of what we need to do is be able to find fast ways and complete ways to make sure that we can test every scenario and make sure our cars are safe. And so I think just in general for the software part, I think just good engineering practices, because it is a safety critical system, to make sure that we analyze all the requirements necessary, all the possible problems it can face, and any failure modes. But just good engineering, I think, is good experience there.
Thank you, Eric. And you're right that there's like the software side and the hardware side for the functional safety. So it depends like what you're interested in, where your skills lie. Janelle, this one's for you. What are the major differences between working for NVIDIA versus Intel in terms of culture and theme?
Yeah, so I mean, I think the one biggest difference is going to be just like the size in terms of like number of employees. So Intel is like has, I want to say, like close to 100,000 people, I guess, like across the world. And I think we are maybe still like maybe 20,000 if I have like around that range. So, I mean, I think what I found is that the team culture varies very differently from team to team, because at Intel, just because it's a very big company, so every organization and every team ends up having their own culture. And personally, the teams I've been to, I think like some of the teams I actually did move around within Intel. I was first with the circuit design team, and then I explored the physical design for some time, and then I explored like the RTL design too. So I think, and after moving to NVIDIA, I found that NVIDIA is a little bit more fast-paced. It's a much flatter hierarchy, so you don't have that many managers above you, and and there is no such thing as organization chart. I think everyone believes to be that we are like the same team, and you can get pulled in to do whatever is good for the company. So I think yeah, I think I would just say that the NVIDIA still has a little bit more of a fast-paced startup vibe where like you can still like, mess around in different areas and you'll get pulled in to do different things rather than just being sticking to your own role. But again, in Intel too, I have been part, and like I have friends who are part of teams who follow the same culture. So I think I know it may be a little bit difficult, like during virtual on-site interview, but yeah, whenever you interview with a company, you're going to be interviewing with different people in the team. Just ask as many questions as possible. That hey, what's the culture like? What is the good and bad about working in this team? And for the most part, I think all interviewers would answer that question like honestly, so that like because they want you to make sure that like if you're joining, you are joining with the right expectation and you succeed within the company too.
Yeah, I can add my 2 cents because I actually interned at both NVIDIA and Intel, and I was deciding between the two, like which one to go back to full time. And it came down to, I think, just the rigor and the methodology we use at NVIDIA to make chips. The standard is a little bit different, in my opinion. Even when I was interning at Intel, we would have these postmortems like, okay, well, our chip came back bad. Like, let's try to understand what went wrong. And like, I mean, I say it casually, but that's like a tens of millions of dollars mistake right there. And NVIDIA is really proud. We always have our A1 silicon, which means just the first design we ship to the fab and get back. We always have that working. That's how we're able to go to market so fast. That's how we stay competitive. And that's like years and years of very like committed and rigorous methodology flows in place. Like even Jensen from the very beginning has been saying like, we need to have good like methodology. So yeah, that was kind of ultimately my decision.
Thank you, Janelle, and thank you, Dora. That was super helpful. Question, what are the location cities available at NVIDIA? We are a global company and we have offices throughout the US. We are currently virtual. But we do have offices throughout the US. Eric is actually part of our New Jersey team and works out of there. Our headquarters is in Santa Clara, California, but some of our bigger offices in the US are Austin, there's Oregon. We also have even a research robotics lab in Seattle. So a lot of different locations for different teams. For ASIC design and physical design rules, is it helpful to take operating systems? I don't think so. Maybe Dora is probably no, right?
Yeah, I don't think so.
Yeah.
Yeah, unless like maybe for verification, maybe, but I would say no, not so much on the hardware side. Let's see.
Well, that being said, we do have
still hiring. Nope.
Oh, sorry. We have a lot of hardware infrastructure roles. Those are for people who like to work on big systems. Like we are making huge projects. We need a lot of infrastructure, and there's like pretty interesting problems there. So people who love like OS and stuff, they want to work in hardware generally go to that side.
Yes, anyone's interested in that. It's a really cool team. How are the job responsibilities and duties different from the CAD team and the physical design team?
So, I mean, I think maybe I can start off and Dora can add on to that. But I think the way I see the difference is that the CAD team is the one which develops the methodology and flow, which is being used by the physical design team. So if I were to just kind of refer to what we do in 627, right? So the actual project where you have to make sure that all the connections are done, it is LVS clean and DRC clean, that is done by the physical design team. But the flow, which like the students end up using, which in most part is developed by the GSIs of that course, is developed by the CAD team. Dora, do you want to add more to that?
Yeah, I think that's exactly right. Like there's CAD, we provide the flows to the designers. They're like our customers, basically. And I work in the front end physical design flows. There's also like like very much like place and route methodology flows. That's another team.
That answers your question. Dora, do you think that, of course, the hardware for ML is helpful to your job?
It doesn't help me directly every single day, but I think those things are good to know. Whenever Jensen is considering, or whenever he's talking about like how GPUs work and like how our competitors are designing their GPUs, I think that gives me some background. And I think once we were in a meeting with one of our VPs of hardware, and he even said, you know, if time comes and GPUs aren't it, like we're not gonna make GPUs anymore. If there's a better computing platform, we're gonna go do that. So I think just knowing about how like computation works in general, like that makes me understand that. And yeah, it's like good to know. It didn't help me every day.
All right, thank you, Dora. I know we have 2 minutes left. I'm gonna go ahead and close up the Q&A. If we didn't get to anyone's questions, feel free to follow up with me over email, and I'm happy to answer anything that you may be still wondering.